Welcome back, students. Myself Sir Sunil, your physics teacher. How are you all? Fine? I hope you all are fine. And these days we are discussing our unit 2nd, physical quantities and measurement. Almost the theory part we have completed. And today we are going to discuss the solved numericals which are given in our book. All of you please take out your book and watch the session carefully. Students, here are our solved examples. You please read the first question. The first question is, a block of glass is 30 centimeter long and 25 centimeter wide, has a thickness of 2 centimeter. Find the density if its mass is 7.5 gram. Okay, students, in this question, length is given, width is given, and thickness is given, and also given that mass. So what we have to find out? The density. Okay, students, for the density we know the formula, that is density D is equal to m upon V, mass upon volume, mass upon volume. So these both are not given here. Okay, students. So what we have to find out first? We have to find out volume V. The length is given, breadth is given, then thickness is given. Then what is the equation to find out volume? L into B into H. Okay. Then here it is, length is 30 centimeter, breadth is 25 centimeter, and thickness is 2 centimeter. By multiplying these three together, we will get the answer 1500 centimeter cube. So now we got V, volume we got. Then we have to find out the mass of a block. Okay, that is given here. Okay, mass of block, that is 7.5 kilogram. So now we have to convert this 7.5 kilogram into gram by multiplying by 1000. Then we will get 7500 gram. Now we got M and also V. So now use the formula, density D is equal to m upon V. Okay, students. So we can write here 7500 gram, that is M. This is M, and 1500 centimeter cube, that is V. Okay. By calculating these both, we will get the answer 5 gram per centimeter cube. This is the density. Okay, students. Now we will move to second question. You please read out the question. A piece of iron of volume 30 centimeter cube. The volume is given here, okay. Volume is given and has a mass of 234 gram. Find the density of iron. Find the density of iron. Volume is given here in centimeter cube, mass is given here in gram. Okay, then we can write, given that mass M is equal to 234 gram, volume B is equal to 30 centimeter cube. We know the equation, that is density D is equal to m upon V. Substitute the values directly here in the formula, then we will get the answer by doing the calculation. We will get the answer 7.8 gram per centimeter cube. Okay students, now our third question. The mass of 10 centimeter cube of silver is 103 gram. So mass is given, that is 103 gram. Volume that is given, that is 10 centimeter cube. What we have to find out the density of silver in kilogram per meter cube relative density of silver. Okay. So here it is given M is equal to 103 gram, volume is equal to 10 centimeter cube. We know the equation, the formula, density D is equal to M upon V. Substitute these values directly here. Clear? 103 upon 10 gram per centimeter cube. What is the answer? 10.3 gram per centimeter cube. Multiply by 1000, we can convert this one into kilogram per meter cube. We will get final answer here for first session. First case 10,300 kilogram per meter cube. Now we have to find out relative density of silver. The formula is density of silver upon density of water. Density of silver, we know that we have already found in first session, that is 10,300 kilogram per meter cube. The density of water, that is 1000 kilogram per meter cube, that's this point we have already discussed in the theory part. So by doing the calculation, we will get the answer 10.3. Clear? 10.3. There is no unit for relative density, you please keep in your mind. We have discussed. Assumption, the density of water is 1000 kilogram meter cube, that is already we have discussed in theory. Okay. Now fourth question. A piece of iron when immersed in water taken in a VIIIA can displaces 25 ml of water. Its mass is 195 gram. Find the density of iron in kilogram per meter cube. So given that mass of iron piece is equal to 195 gram, M is equal to 195 gram, we can convert this 1 gram into kilogram by dividing 1000. Then we will get 0.195 kilogram. Volume of iron piece, V is equal to volume of water displaced. That is already here given in the question, 25 ml. VIIIA can displaces 25 ml of water. So here we can write the volume of iron piece V is equal to volume of water displaced, that is equal to 25 centimeter cube, that is equal to 25 into 10 raised to minus 6 meter cube. Clear? 25 upon 10 raised to 6, that can be become 25 upon 10 raised to 6, that can be written as 25 into 10 raised to minus 6. Theory we have discussed. Now we can find out the density of iron. D is equal to M upon V. The equation we know that density is equal to M upon V. M, that is already we found, that is 0.195 kilogram. V also we know 25 into 10 raised to minus 6. By calculating this both, we will get the final answer 7,800 kilogram per meter cube. Now fifth one, a block of silver displaces 200 ml of water in a measuring cylinder. The block of silver displaces 200 ml of water. Okay. If the density of silver, density is given here, density of silver is 10,300 kilogram per meter cube. Find the mass of block. We have to find out mass. Given that, here in the question given that density, that is equal to 10,300 kilogram per meter cube. Okay, volume of block V, that we know that volume of water displaced, that is also given in the question, that is 200 centimeter cube. That means 200 into 10 raised to minus 6. In previous question we have done same point. So now we know that the equation density is equal to m upon v. This is equation to find out density. But here we have to find out the mass. So mass is equal to v into d. Please listen carefully. Mass m is equal to v into d. That means volume, we know that is 200 into 10 raised to minus 6 multiplied by 10,300 kilogram per meter cube. By multiplying this one, we will get the answer 2.06 kilogram. Okay, students. Now, next question, sixth one. The mass of a copper piece is 44 gram. A measuring cylinder contains water to a level of 12 ml. The water level rises to 75 ml. Initial level it is 12 ml. It rises and reached 17 ml. Mark when the copper piece is dipped in the measuring cylinder. Clear? When the copper piece is dipped in the measuring cylinder, the final level is 17 ml. Find the volume of copper piece and the density of copper. So here we know that initial level of water, that is V1 12 ml, then final level of water, that is V2 17 ml. Mass is given, that is 44 gram. Volume can be found out by the relation V is equal to V2 minus V1. Clear? That means 17 minus 12. The answer is 5 ml or 5 centimeter cube. So now we got the answer for V. Now we know that V is 5 centimeter cube or 5 ml. Okay. Now density of copper D is equal to m upon V. That means 44 upon 5. By calculating this, we will get the final answer 8.8 gram per centimeter cube. Now seventh question. The mass of density bottle is 51.50 gram when empty. 76.50 gram when full of water, and 71.85 gram when full of an oil. Find capacity of density bottle and density of oil. Here given that mass of empty density bottle, that is 51.50 gram. Mass of bottle with water, that is M2 76.50 gram. M3 71.85 gram. In theory we have discussed the same situation, same activity we have done. Okay, you please remember. Now how can we find out the mass of water in bottle? By using the relation M2 minus M1. Here it is M2, that is 76.50 minus 51.50. That will give the answer 25 gram. Since density of water is 1 gram per centimeter cube, therefore capacity of density bottle V is equal to 25 ml. This can be written as V is equal to 25 ml. Now we have to find out M3 minus M1. That is mass of oil in bottle. M is equal to M3 minus m1, that is 71.85 minus 51.50 is equal to 20.35 gram. So, by using the equation density of oil D is equal to mass of oil M divided by volume of oil V, that is 20.35 gram divided by 25 centimeter cube. Final answer is 0.814 gram per centimeter cube. Now, 8th question. The mass of a density bottle is 35 gram when empty, 65 gram when filled with the water, 59 gram when filled with alcohol. Find the relative density of alcohol. Given that mass of empty density bottle, that is M1, that is 35 gram. Okay. Now, mass of bottle plus water M2, mass of bottle plus water, that is M2, is equal to 65 gram. Then mass of bottle plus alcohol M3, that is 59 gram. Relative density of alcohol is equal to mass of alcohol divided by mass of equal volume of water, means M3 minus M1 upon M2 minus M1. 59 minus 35 divided by 65 minus 35. We will get the answer 24 upon 30. By calculating, we will get a 0.8. For the relative density, there is no unit. Now, question number 9. The table below gives the density of some solids and liquids. For each solid, list the name of liquids in which that solid will A. float or B. sink. So, students, table is given here. Each and every substances, density also given in kilogram per meter cube. Okay. Liquids are mercury, water and glycerin, solid, iron, wood and cork. Whether it will sink or float, that is question. Okay, students. Now, first we are going to consider about iron. See, iron, the density is 7,800. 7,800. Iron will float on mercury only. Why? The density of water and glycerin, that is less than iron. So, floats on mercury and sinks in water and glycerin. Okay, students. And about wood, what it is? Floats on mercury, water and glycerin. Wood. See, here it is wood, density 700, and all three densities are more than this 700. Okay, more than this is less, more than this 700. So, wood floats on mercury, water and glycerin and sinks in none. Then now coke. Coke also same as it is. The density of coke is this much only, but density of these three, you see, more than this 250. So, coke will float on these three, but sinks in none. Sinks in none. Okay, students, these are our solved numericals, and also this is the last portion of our unit. Okay, last topic of our unit, and tomorrow we will discuss exercise numericals. And tomorrow also you come with your rough copy to do the numericals. Okay, today it's a time to wind up this session. Thank you and have a nice day.